this primary wastewater treatment techniques that we would start now. But before that, let me tell you, we would not generally discuss much about the screening and filtration part, because this is the very basic part I have said. But this is there is the method of screening method of comminution, that I will not discuss mostly, but we will start with the primary treatment techniques. At this juncture, it's pretty important for all of us to understand the difference between the what is the expectation about the water. Suppose this water is coming out from a source, any source, say coming out from an industry, coming out from a sewage pump, coming out from a typical say a process like something like food processing waste. What are the expectations of the water? I mean, having seen the water or coming out of a particular industry or a process, we should try to understand what we should expect in that water. Say in a food processing waste, water would have high BOD. Essentially it would have high BOD, but it will have less, say inorganic TDS, less inorganic TDS, may have some salt, may have in that, less on inorganic TDS. So here, but on the other hand, say a mining related wastewater, or say wastewater where there are only the substances, the mixing substances are of inorganic nature, we would only observe inorganic salts present in that. So in the most of this mining wastewater, acid mine drainage or whatever we discuss about, we will deal with that also, acid mine drainage and all this. We generally observe the water to be of a certain characteristics. The characteristics is initially wherever it is getting produced, there will be the environment would be oxygen deficient. This is number one. The second point that we would observe in such cases is there would be very little BOD, because mining as such, the process does not create any place for BOD to be produced. So what we would find is this would be high TSS, high TDS, but this high TDS was basically due to inorganic contents of different kinds of metal cations and anions. Okay. So having said this, so now if you can make, it is important to differentiate between industrial and sewage or civic wastewater, though most of the wastewater engineering today is mostly this part of wastewater engineering is highly developed, is quite well developed, civic and town wastewater treatment methods, but industrial wastewater treatment is still in the process of development. There is a lot of things still required, a lot of research inputs are still important. So what we find is that the industrial wastewater may or may not contain, as I have said, industrial wastewater may or may not contain high BOD, right? It may not contain high BOD. It is not necessarily some industry like sugarcane industry or sugar industry. There may be high BOD, but not in all. Say something like a process, a chemical process like mineral processing. The waste cannot have high BOD. Mineral processing, the waste will not have high BOD. Say similarly a method where say sulfuric acid is produced, a chemical plant, or a particular any other chemical being produced. There you will not find high BOD. The BOD would not be important parameter there, though we measure BOD, but it's not, maybe may not contain, mostly may not contain high BOD. Say this mostly there would be less organic material, but they would be mostly oxygen deficiency, oxygen depleted, they would be mostly oxygen depleted. And finally the most important part would be they would be having enriched metal cations and sulfate, carbonate, bicarbonate anions. Okay. So this is industrial wastewater, but say civic wastewater on the other hand, civic or sewage wastewater, civic wastewater on the other hand will be necessarily high BOD, say less organic matter, I mean comparatively less, organic material. It would also be oxygen depleted. It will be deficient in oxygen. You may or may not accept some of these metal cations and sulfates, etc. Another very important thing here is high in nitrogen, high ammoniacal nitrogen. High ammoniacal nitrogen. So, this is the difference. So, you can see depending on this process, depending on these purposes, the total treatment method would be different. Treatment methods would be different, but nonetheless, there are several methods, which are true for say civic and wastewater treatment. We will deal with them because just to explain you what are the basic principles of the treatment, what we would really like to attach with this. The one very important thing is a trickling filter. Trickling filter. This is where we are dealing with the primary treatment techniques. There is a trickling filter. The trickling filter is like this. What is generally done in a trickling filter is like this. This is particularly what is this influent is entering into the column like this. Here you can see it is nothing like what you observe in a bathroom spray or things like that. The water goes and sprays. Okay, yeah, it's like a fountain or a spray like that. You can see here this would be the sprays. Here would be the perforations should be there through which this water would be passed into this. Particularly this one is it is a packed granulated rock, or it can sometimes we are using nowadays say zeolites also. Zeolite beds, zeolites, or even polymers also is polymers, synthetic polymers are being used. What is this they do is, you see here the water finally is the most important part here is to understand is that this water finally forming like this, traveling across this different pebble surfaces, the rock surfaces, and then finally coming out from the bottom. So here this water trickling from here and things like that, as soon as this, the two purposes are served. Two purposes, the water begins to trickle through this granulated rock or zeolites or synthetic polymers packed with that, and two things are achieved. One is the reduced velocity, so increased sedimentation, increased aeration. It also means increased settlement of both increased settlement of organic and inorganic substances, inorganic and organic substances. So you can see this, this is particularly, so after having coming from there, through this chamber, through this channel, this water that would be collected here, would be generally taken out, through the ports here. So this is what would be, you can see this water going out through an effluent like this, okay. So here this water is going out as an effluent from the chamber. So you can see, if you just try to observe from a plan, you just this across, say in about, if you just make a section along this line, around this x dashed, if you make a section, what you observe is that there would be small perforation on these surfaces, small perforations on them, the small perforations that we see generally in all surfaces of this nature. So through which the water would be allowed to pass, and small perforations should be there, and on top of that you will find the pebbles settle like this. So here, if you see this, in a section like this, so water trickling through these surfaces at a much reduced velocity would essentially go down like this, and as a result of which there would be in the surfaces we will find in the surfaces, due to natural processes, the sediments should be collected. So these sediments need to be regularly cleaned for the effective use of this substances. So here two important things are to be noted here. There is the increase in the area of contact, slowing of velocity, increased aeration, all leading to increased sedimentation of different substances, inorganic and organic, both nature, both inorganic and organic, isn't it? So this is how this surfaces, if you just see this is across, even if you don't see the full part of it, if you just make a section instead of this x dashed here of this section, it would look like this. I have not, if x dashed, I have not drawn this, so I am just trying to limit to this particular part. Here it would be looking like this. So here this is a trickling filter. So this is a very interesting and very typical type of water treatment methods. Much of this, I tell you one thing, still today much of this can be achieved. A great amount of water filtration can be achieved if these kind of small, typical, very simple systems are very effectively used. I can tell you with all my understanding about the subject is, the earthen filters that we used to see, in our childhood, even say in my childhood especially, say in cases like that, they are as effective as many of the water mechanical or electronic filters that we have observed today. They are equally effective. Only most important thing is that has to be maintained. You don't expect that that this would be set up for, in countries like ours, the problem is we set up a plant and then forget about it. We do not make much effort to maintain it. If we maintain it, this can itself serve a lot of great purposes. They can be as effective as secondary treatment methods. So here this is about a trickling filter. As another very important part is, that is generally is called is a rotating biological contactor. Rotating biological contactor. Rotating biological contactor. Let me make a drawing first. This is how it looks like. You will find this, in the textbook also. You will find this drawing here. But try to do the drawing. I'll make some changes in the drawing because of okay. It should be like this and then this. Okay. Don't take this. All right. So here this one is how it is going, like is this. Sorry, here this would be an opening there, this would be an opening there also. So okay, so you see this is what is, this is what is where this is primary settling is taking place. Primary settling, taking place. You can see this primary settling tank, you can generally take it out, right. This is what is a rotating biological contactor, is a rotating biological contactor. Let me explain how it is. Is basically, if you just observe it, it would be like this. These are basically rotating discs of these rotating discs. If you just observe this thing like this, so you can see this is how they would look from one view, or else you can say it like this, they would be like all right. You see this is how the tank is, on which there would be water, coming out, going out like this, coming in and going out like this. So here the water would enter, this is how the water would enter, and this would be, they would be connected, these are called rotating, because they rotate either powered or with the flow of the water. Rotating biological contactor. So what happening is, as I have said, this oxygen, this water is O2 deficient, so the reaction rate drops down. To a substantial amount. So the reaction rate actually comes down. So to increase the reaction rate, it is an important thing. It is essential. That we increase the concentration of oxygen in the water, and this can only be possible, where we are just allowing some of the water in turn, in the process of a wheel to come in contact with the air, and as a result of which increased aeration taking place. This is a typical biological rotating biological contactor. There will be 3 streams or 4 streams like this, then it would finally go into a secondary settling tank. So you can see this in the secondary settling tank. This is what is a secondary settling tank. What is another interesting thing that takes place here is, another is basically, this is called activated sludge, this activated sludge is generally sent back here. Some of these sludges that would be some of the sludges that would be produced here, see the sludge that would be produced here, selectively it would be brought back and would be supplied into this water. The reason is very simple. The reason is, this water, the microbial activity in this water would be much less, because this is a fresh wastewater stream. Whereas on the other hand, here this is completely enriched with microbes. Large number of microbes are present already there. So these microbes would be generally put into this stream back to this stream again, and as a result of which, the oxidation, the reaction process would increase. It's something like you have seen the preparation of curd at home. What do they do is, the curd, part of the curd would be left, kept aside, and would be mixed with the milk, and so that the process of the curding takes place. Okay, the same thing takes place here. The same situation is here also. What we are keeping? We are essentially keeping something with lot of microbes. The microbes that would be actually transfer the milk into a curd. This is a typical microbial action. Very simple microbial action. You see this, the total characteristics of this, the milk would get changed, and this is completely microbially controlled, complete microbial action taking place. To control this microbial action, sometimes what we require is to do it fast, to do it in a controlled manner. Some of these microbes, the preferred microbes, or some of those microbes which would be found in the waste of the sludge of this secondary settling tank would be reverted back to the primary settling tank again. Okay. So as a result of which, in this process the decomposition of the organic waste and also different chemical precipitation method also can be applied. A large part of that would also be involved in the chemical precipitation methods. Chemical precipitation would also takes place. One is that the two purposes of this is that this is biological action for treatment of high BOD wastewater. It also helps in increased precipitation. Helps in increased precipitation. This is another very important part. Biological action for treatment of high BOD wastewater. The purpose of using this rotating biological contactor helps in increased precipitation. Also helps in increased precipitation of, say, hydroxides, then you can say sulfides, sulfates. Okay. Ideally a process suitable for civic wastewater, but this one can also be used for the purpose of increased sedimentation of, say, a number of inorganic chemicals, number of inorganic substances. Okay. So it serves two ways. This is called a rotating biological contactor. These rotating biological contactors are also in great use. Is various purposes they are generally used. Particularly, they are also another important part is combined treatment. Where combined treatment. In some cases this rotating biological contractor or trickling filter may be combined with a principal treatment technique, so that to augment the process. To augment the process, we would require that to speed up the process. It is required some kind of pre-treatment is required of the waste, pre-treatment. So, these are basically very good pre-treatment methods, where we are trying to, before the final settlement takes place, we are trying to pre-treat the waste material, pre-treat the waste material in water, so that they become more attuned to sedimentation at the later stage. We will see particularly in organic treatment, this kind of situations or this kind of techniques are very important. I mean, a pre-treatment, cases for pre-treatment can be used. Another very typical, I mean, if you are not doing any kind of wastewater treatment, the essential, very essential part is, in many cases in your households or wherever, if you are just trying to use, if you are thinking of using a generally polluted water for some purposes, say irrigation, or say for say something like at least feeding the livestock, cows and buffaloes and things like that. One very important method of treatment technique process is oxidation pond treatment. Oxidation pond. It is particularly of great importance to countries like ours, where we should have an oxidation pond. What is an oxidation pond? This is an oxidation pond is largely, say, the effluent would be generally sent into is most ideal is the earthen tanks. The earthen tanks, which are generally shallow, very shallow in these earthen tanks. You can see them as very shallow earthen tanks. Although sometimes the affluent height of the affluent and this height, this is mostly the same. So, here this depth is 0.3 to say about 0.4 meter, or say about 30 centimeter to 40 centimeter. Here as this one can be as width as possible. This is not necessary that this one can be as long as possible. Sometimes it is better between 500 meters or say 500 meters to it can be up to 1 kilometer. So, this is typical wetland. If you have seen the wetlands, typical wetlands where there is a very small width of the water, the depth of the water is very small. This particular surface, you can see this particular surface, say here the water is being dumped here. This is either brick or clay. Clay is favored, clay construction. This is basically an earthen construction. You can see this one would be 500 into 500, say 25, say 500 into 500. So, 500 into 500 say meter square. So, you can see this meter. So, it is about say 25 into 000 the square meter of width, square meter of area, very wide but very shallow also. What happens we generally do is we say this effluent water. If you just allow the effluent water, this can be this particularly, this is this particular area is a catchment area. This can be a say river catchment, area, which would be suitable for an oxidation treatment like this. What we are trying to do is, here there will be, it would be a good supply of sunlight, we would observe that initially is basically till we observe say about 1 to 0.1 to 0.1 to 0.125 meter, we observe mostly a good oxidation as a aerobic column, and particularly below this up to a certain depth, after a certain depth, say between say 0.2 to say 0.25 0.25 to 0.4, this depth, at this depth we find an anaerobic column. Depending on the load of the waste, depending on the load of the waste, we find that about this about this column there would be an aerobic column, there would be an anaerobic column. What would happen is, in the aerobic column, what we find is, as I have said, mostly in an say sunlight, and then aerobic microorganisms. You will find CO2, you will find H2O, then you will find say CO2, H2O mostly, and stable compounds, several stable compounds. You will also find some H2S here. You will also find some nitrogen, say in the form of say NO2, or say in the form of NOx. Okay. On the other hand, in this anaerobic column, if you see column is CHO, say N, or any other substances, pH, for P, phosphorus, all these substances connected with reduced oxygen, sufficient oxygen here, reduced oxygen here. You would find that under reduced oxygen, reduced sunlight, reduced or no sunlight, anaerobic microorganisms, anaerobic microorganisms, we will find carbon monoxide, we will find water, we will find some H2S also here, mostly H2S. You will find some kind of methane also being produced, and you will find say unstable compounds, other unstable and odorous compounds. So here in this anaerobic column you can find this. Apart from this, there will be many things to deal with this inorganic components also. A large part of inorganic substances, like say iron, say here, in case you can also observe another important reactions taking place in this column itself. We will find that Fe3 plus with say increased finding FeOH3, which would be settling. We would also observe that ferric hydroxide deposition taking place. So this is also known as an oxygen. This is suddenly reducing TDS. So reducing TDS. So you can see this is the part in oxygen ponds. This oxygen pond generally helps us to obtain. So these are the purposes. These are the typical. These are very simple type of the primary treatment methods that we generally use. These primary treatment methods, you see that we have not used any material. We have just generally encouraging the natural reactions to take place, and as a result of which, without much cost, we are able to reduce the concentration of pollutants in the water. Reducing the concentration of pollutants in the water is a major significant step, because by that time, if you are reducing the concentration of several substances in water, the reactivity of the remaining substances increase. So that is how it generally serves a purpose in carrying out with a method, this kind of methods to treat water. And initially, mostly when you are trying to do initial processes, this kind of methods generally help. We will continue the discussion here. We will continue the discussion, and the next class we will still discuss on the different other methods. All right. Okay. Any question?
So treated water is again useful for drinking purposes?
Depending on the standards that you meet. Suppose there are three kinds of you say in water generally, what we are say that varieties are like this. Say water treated water, there are different purposes for use. Say the first level is say for aesthetic use, aesthetic purpose. Say when we are trying to do say in a park, or we are using in a pond, so you want the water to be clear, so that people generally get drawn to this. But that water is not essentially drinkable water. You do not expect that to be drinkable water. This kind of particularly, this is aesthetic purposes. That is also for that also in many treatment. Okay, not only for drinking. The next comes is industrial water. Say hardness. Reducing hardness is an important part of industrial water. In industrial water, we should have hardness very little, because hardness increases the carbonation process inside. There will be many kind of difficulties that arise out of this processes. So the after aesthetic purpose, the industrial water that we use for industrial purposes. Next comes is the drinking water. So maybe in many cases a primary treatment method may not be sufficient to make the water good for drinking, but the secondary treatment may be required, a tertiary treatment may be required for this to make it sufficiently potable water. That we will see later, where we can use the water that we have said. In most cases, these are used for aesthetic purposes and industrial water. They are not still good for drinking water. In drinking water, we require certain other requirements also. We will deal with this. We will discuss with them drinking water. So, all right. So this is how we will see that later on. Okay.